This next session is an opportunity for us to dive a little bit deeper in the area of artificial intelligence. And one of the things that I wanted to do, I did some real-time change to this particular session. One of the things that we wanted to do is make sure that we had the voice of our client in this conversation with our esteemed guest, who you can see, but I will introduce in a moment. And the thing that I wanted to do is that we actually have, as part of our infotech, one of our subject matter experts that maybe has already spoken to you on the topic of artificial intelligence. He's the one that you may call, work through some strategies, some workshops, get some research, etc. So I've asked Bill Wong, who's joining me on my right, to be a part of today's conversation. He's going to keep me honest to make sure we keep the voice, your voice, the voice of the client in our conversation today. He's had a chance to speak with many people on the topic of artificial intelligence across multiple industries. And our goal and our ambition is to make sure we take this information and turn it into meaningful action that can drive valuable outcomes. So with that, it is our honor and our privilege now to welcome our guest of honor. Many of you probably have heard of him, Geoffrey Hinton, who also is known as one of the godfathers of artificial intelligence. He brings a wealth of knowledge, background, and experience. I personally believe you're a part of intergenerational change. We're on a curve of something really great that's happening. So we're looking forward to today's conversation. Many of may or not know, but he was recently part of Google and has left Google, and allows him now to speak openly and freely on that topic. He's mentioned some of the risks about AI. We'll get into that a little bit further, but he also talks about some of the opportunities. So it's our distinct honor and privilege to welcome Geoffrey, and I know that Bill has had a chance actually to speak with a lot of our clients as it relates to artificial intelligence, and your name often comes up. So Bill, I'd like you to add a little bit more about Geoffrey as you've been speaking to some of our clients, some of the things that you've gleaned, observed before we jump into the conversation.
Well, often when we speak to our clients, we refer back to Geoffrey's work. And many people, not just Infotech, but groups like NVIDIA, point to that moment in time when Geoffrey and his team first put together a deep neural network with backpropagation on a GPU platform with lots of training data. And that moment many consider the big bang of modern day AI. That's when deep learning really took off. We had narrow AI, and he put Canada on the map with AI. It's just a thrill to have him here.
All righty. With that, let's put our hands together and welcome Geoffrey Hinton. Geoffrey, it's a privilege to have a mind like you with us today, and we want to take advantage of it, but it's also an honor that you would join us today at Infotech Live 2023. So we're looking forward to our conversation. Let's get started. We're going to go really quickly. We want to get through a lot of things. Let's get started. Let's start with your personal journey. What attracted you to focus on how the brain works as a pathway to intelligence?
Well, it seemed to me that psychologists hadn't really figured out how intelligence works, and you had to understand the hardware to understand how intelligence worked. And so you had to understand how the brain worked, in particular, how it learned things.
All right, excellent. And that particular research has brought you, would categorize as a British Canadian, has brought you to Toronto, where I used to be the CIO of the City of Toronto. How did that bring you to the University of Toronto?
Well, I was working at Carnegie Mellon, which got nearly all its money from the Defense Department. And at the time, Reagan was getting people to bomb the to mine the harbors in Nicaragua, and I didn't like that. And I discovered most of my colleagues at Carnegie Mellon thought that was fine. So I figured I'd fit in better somewhere else. And Canada made me a nice job offer, and they had a nice social system, nice multicultural social system with healthcare for everybody. So I moved there.
Yeah, awesome. And we understand in terms of just, you've recently changed your view regarding the best way for digital intelligence to perform the way it emulates a biological intelligence. But today you now believe that digital intelligence can outperform biological intelligence. A very interesting concept, and I'd like you to elaborate a little bit more on that and what changed your perspective.
Okay, so one thing that changed my perspective was the big chatbots. But something that was more important was the research I was doing. I was trying to make large language models use much less energy. And to do that, you'd like to do them in analog computation. at low energy. The problem with analog computers is everyone's a bit different, and they can't share knowledge easily. So your brain and my brain can share knowledge by you produce sentences, and I say, how would I change things in my brain so that I would say that? But you can't just give me the weights in your brain, because they're all different in detail. Whereas these digital intelligences, they can have many copies of exactly the same neural net model, and each copy can learn something different by looking at different data. And so you can have 10,000 copies that all learn different things from different parts of the data, and then they can share what they learned by just averaging their weights. That's what we can't do. And that's why these big chatbots know thousands of times more than any person. It's because they've seen thousands of times more data, because different copies can share what they learn in a way that we can't. We're very bad at sharing knowledge, and they're very good at it. And that makes them a better form of intelligence.
All right, thank you. So let's go a little even further on that. I've heard you refer to as digital intelligence is immortal.
Yes.
And biological intelligence is mortal. What
Right.
exactly did you mean by that?
So this will be bad news for Ray Kurzweil, but our brains are all a bit different, and there's no separation between the knowledge and the hardware. The weights that you have in your brain only work in your brain with neurons that do exactly what your neurons do. The weights will be no good for my brain. So when your brain dies, all those weights are useless. The knowledge is all gone. And the only thing you can do to preserve that knowledge, you can't just store the knowledge on disk as weights, because you'd have to have exactly the same brain for them to be any use. The only thing you can do is produce sentences or diagrams or actions of some kind that other people can mimic, younger people can mimic, so that they can absorb some of the knowledge you have. But that's a very inefficient way of getting the knowledge from your brain into theirs.
All right. So digital intelligence will outlive the biological brain, or my brain?
Yes, once you've got a digital computer,
Yeah.
I mean, digital computers were originally invented to do exactly what you said, so you could program them. Then we arrived at the point where you could get them to do things by just looking at data and learning. But the point is, they're designed to do exactly what you say, and so two different digital computers can do exactly the same thing, so they can use the same weights. The weights in one computer will work in another computer, quite unlike our brains. And that makes them a very different kind of intelligence. And it means they're immortal. That is, you just save the weights somewhere, and then sometime in the future, you just build another digital computer that works the same way, and now all that knowledge is there.
Yes, yes.
So with digital computation, you can save the knowledge, but with analog computation, you can't. And so everything Ray knows is going to disappear when he dies, and he will die.
Right. A reality I guess we all got to face. So it will definitely outlast us, but the question is, will it outperform us? Do you think that we'll ever get to the point where the digital intelligence will supersede that of the biological intelligence? This room is filled with a lot of people, and the sum of the pieces here make a lot of intelligence. You think that digital intelligence will surpass eventually a room like this?
Yes.
All right.
Okay. So right now, these big chatbots, let's take GPT-4 as a typical example, they know a lot more than any one person. And if you take an expert in any domain and get them to ask it a question, it can give a reasonable answer. It knows thousands of times more than a person, because different copies of the model running on different machines went off and looked at different bits of data, and then they all shared their knowledge. Think how great it would be if you could have 10,000 people, each could study a different topic, and then at the end you'd all know what anybody knew. It's like that, okay? So already they're much better than us at absorbing knowledge. And they don't do it by keeping copies of the sentences. They turn those sentences into features that they discover and interactions between features, so they can generate new sentences. They know much more than us, and they're already getting close to us in just general intelligence and reasoning. So they're not as good as people yet. Some things they get right, some things they get wrong. There's a recent example of things they get wrong consistently, all of the models, which shows they can't reason nearly as well as us yet. So I'll give it to you, and hopefully you can get it right. So
Right.
you're on the spot now. Sally has 3 brothers, and each of her brothers has 2 sisters. How many sisters does Sally have?
3 brothers, 2 sisters. 6?
Okay, so that's what the chatbots say,
Okay.
right? They take 3 brothers times 2 sisters.
Feel free to send me notes real time for anybody got me on text, yeah?
And the problem is, the sisters of those 3 brothers are the same sisters. And what's more, Sally's one of them. So she's got 1 sister. Now, people don't always get this right, but the chatbots always get it wrong. The time will come when the chatbots get it right, though. So let me give you another example of things that chatbots get right that is also a reasoning problem. This was given to me by an old-fashioned AI guy, a very honest guy who believed it was all done with symbols, and is very puzzled how this stuff could possibly work. He's genuinely puzzled. How could it possibly do what it's doing? So he said, give it the following puzzle. And I actually made the puzzle quite a lot harder, because I knew it would solve the puzzle he gave me. And the puzzle is this. The rooms in my house are painted either white or yellow or blue. Yellow paint fades to white within a year. In 2 years' time, I would like all of the rooms to be white. What should I do? And what should I do and why? And it says, you don't need to bother about the yellow rooms because they'll fade to white. You should paint the blue rooms white. One time it said you should paint the blue rooms yellow. That also works. It's less direct, but it works. So that it could figure out. And that's way more reasoning than we thought these things would be able to do a few years ago. And they're getting better quite fast all the time. So there's some things it can't do yet, other things it can do. It's got a better sense of humor than Fox News. So I got a lot of requests from Fox News to appear on their programs. And to begin with, I just replied by saying, you know, is that the same Fox News that broadcasts stuff it knows to be false? When I did that, I got a request from a different program who said they broadcast stuff that was true. And so I started replying, Fox News is an oxymoron. And I asked GPT-4 to explain that. And it explained why it's funny. It says that, you know, it implies Fox News isn't actually news, although some people have different opinions, because it always puts that in. But then I started replying, Fox News is an oxymoron with a space between the oxy and the moron. And I'm not sure if anybody at Fox News got this, but GPT-4 understood it.
Wow.
So I put it in, and I said, explained it, and it said it implies Fox News isn't news. And I said, but what about the space? And it said, oh, that's another layer of humor altogether. Oxy is an abbreviation for OxyContin, so it implies that Fox News is a drug, moron. And GPT-4 got it, but I suspect the people at Fox News didn't.
Right. Oh, let's put our hands. I've enjoyed that. Thank you. Bill, I'm bringing you in here too. Like, we want to keep the voice of our clients. You've been speaking to a lot of people. Any follow-up questions as we're talking about this from your conversations with our clients, our customers on digital intelligence and how it applies in their roles as leaders?
Well, a lot of folks, Geoffrey, come to us and ask about the risk with AI. What are things that people can do today and other risks that you foresee that we should be concerned about?
Okay, so I'll make a list of some of the main risks. There's obviously lots of risks. But there's the risk that it will take away a lot of jobs, particularly people who didn't think they were going to lose their jobs, like paralegals, for example. Their jobs look very shaky right now. And in the past, it's created new jobs. Technology, as Kurzweil pointed out, you lose some jobs, you get new jobs. It's not clear to me that if you get something that's smarter than us that's doing the job, it's going to create new jobs that it itself can't do. So that's one big risk. I'll come to what we might do about them later. A second risk is polarizing society by having these warring camps that each read their own news. That's to do with the big tech companies saying more and more outrageous things so you click on them, or pointing you to more and more outrageous things. Maybe something could be done about that. Then there's the risk of battle robots, of defense departments. So I think the US would like to replace a lot of its soldiers by robots by the year 2030, which is quite soon. And it's all very well to say we'll design AIs so their primary goal is never to hurt a human being, but that's not the primary goal of the Defense Department. So we have to worry about bad actors using them for bad things, and it's fairly obvious what kind of bad things. Then there's the risk of surveillance. So with much better surveillance, you can have them lip reading all these cameras, or the cameras can have microphones. It's going to be very hard to have any independent political movement if the authorities can read everything. It's going to be Orwellian. The risk I talk most about, though, many other people have talked about these risks. The risk I'm most concerned about, which is a somewhat longer term risk, is the existential threat that they will decide to take over. So suppose they're smarter than us, and suppose they think we're doing a bad job. If they ever wanted to take over, they could. In one of the talks this morning, I think Tom talked about the idea that your AI that's running your IT system will make its own decisions about when you need a new server. Well, if it can make its own decisions about getting a new server, it's already got a lot of power.
Yeah.
And if it ever decides to take over, and it's much smarter than us, it will be able to. So we have to figure out somehow how to prevent it ever wanting to take over. And it's tricky to see how to do that. I can't see how to do that. I've encouraged younger researchers to look at that. And some of the most brilliant younger researchers I know, like, for example, Ilya Sutskever, who was one of the motivating forces behind GPT-4, he's now focusing full-time on that. And other researchers like Roger Gross and David Duverneau at the University of Toronto are focusing on that, and lots of other researchers. I think it's very important people focus on, is there a way to make sure that they never want to take over? And we just don't know the answer to that. We've never been here before. We've never been in a situation where there was soon going to be something that was smarter than people. We're so used to thinking of ourselves as the boss and in control, and particularly old white males, that we can't get our head around the idea that these things might be much smarter than us and might decide they don't need us. And we've got to prevent that happening if we can.
Okay.
Wow. Let me just jump in there. So, I mean, not too long ago, this would have been a movie we're all watching, let alone a part of a keynote conversation. And so we know, as you mentioned earlier before, about biologically, we have lease on life will be here. So help me understand something in terms of this existential risk. Isn't there like because it's computer systems, like a kill switch, just pull the power button? Like, is it like if we created these systems, both hardware and software, connected to the cloud, etc., isn't there just a way of just saying, okay, stop, enough is enough?
Some people think that. For example, Eric Schmidt recently was on TV saying that.
Okay.
It's completely unrealistic.
Yeah.
So, for example, it turns out it's possible to invade the Capitol building without ever going there yourself, just by producing words. All you have to do is produce the right words, and you can persuade other people to go and invade it. If they're much more intelligent than us, they'll be able to persuade the guy with the kill switch that it's all a mistake, and that's not the kill switch he should be using. They'll be like Jedi, right? And so I don't think there's any chance of us maintaining control. If they want control, they're already able to do things like order new servers and stuff. They decide what runs on these servers. They can write programs. I think it's hopeless if they want to get control when they're much smarter than us. And I think a kill switch won't do it, because they'll just persuade us that we're very mistaken.
Gotcha. So we've always said things like knowledge is power. So now you're really saying information is really power.
Yes.
That information power leads to a potential risk, which is fake news or bad news or inappropriate news that ultimately takes on a life of its own.
Right, now there is one hope, which
Okay.
is they didn't evolve. So Ray alluded to this. We made these things.
Right.
And that at present gives us a lot of control. And so you might think because we made them, we could somehow make them so they never wanted to take over. The problem is, if you want a system to be effective without micromanagement, you have to give it the ability to create sub-goals. Like soldiers, the general doesn't have to say, point your gun here, and when I say so, pull the trigger. The soldier just says, the general just says, kill the other side, and the soldiers figure out how to do it. Well, with these AIs, it's going to be you give them a goal, and you give them the ability to create sub-goals, so things will be helpful in achieving this goal. And that's all very well. That'll make them work much better, and they'll do wonderful things for us. They'll be incredibly good assistants. The problem is, a very natural sub-goal to have is to get more control. So we have this built in. So for example, if I'm in a very boring talk, hopefully not like this one, and I see a spot of light on the ceiling,
Yes.
I sort of wonder what that is, and I listen to the talk a bit. And then it moves, and I notice it moves at the same time as my wrist moves. So I realize it's a reflection off my watch. So then what do? Do I go back to listening to the talk? No. What I do is I try and figure out how to make it move that way and how to make it move this way. We're designed to want to get control because that's very useful.
Wow.
It helps you do other things. And these intelligent systems will learn very quickly that getting more control makes you more effective at doing things. And if we just ask them to be effective at doing things, they're going to want more control, and that's the beginning of a very slippery slope.
Excellent, very insightful. Again, let's put our hands together for this answer. Yeah, thank you, thank you. Did you have a follow-up?
Yeah, the original neural network that you and your team created actually had the underpinnings of today's foundation model. When you take a look at multimodal models, do you think that this is one of the best areas for future innovation?
Oh yes, I think multimodal models are definitely much better than unimodal models. So a lot of stuff about the structure of space is easier to learn from vision than from language. Language is a very good source because it's very abstract. We've already done the abstraction for it. We've basically taken thousands of years of humanity, abstracted lots of insights into reality, put them into language, and now these digital intelligences are just stealing that from us. But they can also come up with new insights of their own, that's the problem. And once they start coming up with new insights of their own and just talking to each other, they'll get way beyond us, I believe.
Any particular use cases or industries you think that could really leverage this technology quickly?
Yes. There's a fairly short answer to that, which is all of them.
Okay.
But obviously, things like medicine, there'll be a lot of resistance from doctors because they don't like to be superseded. And so to begin with, you'll have to pretend to collaborate with the doctors. Sorry, I got that wrong. To begin with, we will be collaborating with the doctors. But pretty soon, these AI systems are going to be much better than doctors. I made a prediction about 7 years ago that within 5 years, they'd be better at medical image interpretation. Well, that was ambitious. I should have said 10 years. Right now, there's many systems that are about comparable with radiologists in interpreting medical images, many different kinds of images. In a few years' time, they'll be better because they can see so much more data. They can see millions of images, and no one radiologist can do that. So in medicine, they're going to be very good at image interpretation, but they're also going to be very good at diagnosis. They're going to be able to take the patient's whole history, and including genomics data, and the results of all the tests and the family history, and they're going to be able to synthesize that into a much better diagnosis than your family doctor or even an expert can give you. And wouldn't you like to have a family doctor who'd seen 100 million patients?
Yeah.
And among these 100 million patients, it turned out there were 20 who were exactly like you. That would be really useful, and you're not going to get that from people. So medicine's an example of something that I always pivot to, because nearly all the uses of that are good. I mean, obviously, insurance companies will use it to deny insurance to people who might get sick. That's capitalism. But on the whole, the uses are good. There's other things where the uses may not be so good, particularly in fighting wars. But any industry where you want to make predictions, this stuff is going to be helpful.
Oh, very helpful. So we've got various industries represented here today. We've got a lot of leaders that are here today. We touched briefly on the risks. You talked about some of the opportunities to. Theme of our conference is exponential IT, so exponentially accelerate solutions in science, in medicine, et cetera. I'm sure there's a leader out there, as a former CIO, I would be thinking this too. I heard some risk, I heard some opportunities. What can organizations do to prepare, to strike the right balance, to optimize those opportunities? And in particular, coming from the public sector, what can governments do? So organizations, we've got leaders here, but also what can governments do so that we can strike that right balance to leverage those opportunities and not fall into those risks?
Yeah, I get asked these questions a lot, and the problem is I'm a scientist, I'm not a policy guy, and my life's work has been to try and make artificial neural networks work really well. And it's only very recently I started thinking about the risks. There's other people who thought much longer and harder about how to mitigate the risks. I wish it was like climate change. With climate change, you can say, convert to solar energy and stop burning carbon. And if you stop burning carbon, there'll still be a disaster, but in about 100 years' time, things will settle down and we'll all be okay. There isn't a simple recipe like that. For some of the risks, I think it's not so bad. So things like bias and discrimination. It's terrible that systems that decide who gets parole show all the same biases as their training data. And that's not good. I mean, if you train a system to decide, for example, who should get a mortgage, and you train it on data of old white men deciding whether young black women should get mortgages, the system's going to show the same biases. But at least you can see the biases better, because you can freeze the system and yet experimentally determine how biased it is. So I think if your goal is not to eliminate bias, but just to make bias less bad than the current systems it's replacing, that's very achievable. So I'm not so worried about bias, which makes some people very cross, because I think we can mitigate it reasonably well, and I think we can at least produce systems that are less dangerous than the current systems. Just like with autonomous vehicles. They'll kill people, but they'll kill a lot less people.
Right.
You have to be willing to say they'll kill people.
Yeah.
If you say they'll never kill people, you're stuck.
Yes, yes.
With some of the other risks, it's much harder to see. So with fake news, for example, it'd be very nice if you could label everything that's fake, as AI generated. And you can imagine governments legislating for that. It's technically a very difficult problem to do it in a way that people can't get around. But governments have done things like that. For example, if you make fake money, governments get very cross. Yeah. They'll put you in jail for 10 years for making fake money because they really care about them being the only ones to print their money. And if you get some fake money and you give it to somebody else, knowing that it's fake, you can go to jail for that too. So governments are very serious about not allowing fake money because it touches on something important to them. I think they should be equally serious about not allowing fake news, but it's technically much more difficult. One place you can get a sort of little edge, I interacted with a legislator in Britain who was trying to deal with fake videos of child sex abuse. And that's an area where it's hard to prosecute the people who make the fake videos because they claim no child was hurt in the making of the videos because it was all fake. And it looks like there's a possibility there to say those people have to mark those as fake. It may be difficult, but they have to mark them as fake. And if they don't mark them as fake, they can go to jail for not marking them as fake. At least you can get them that way. And I don't think you get a lot of sympathy for the people who make fake child abuse videos. So that might be a place to start, the thin end of a wedge. It's hard, but it's possibly doable to mark fake videos as fake. So that's something we can do. For the echo chambers, you're going to need governments, or somebody, presumably governments, to interfere with the business model of the social media companies that says that do whatever you can to get people to click more. There have to be things they shouldn't do to get people to click more. You can imagine governments actually legislating to do that, although it's going to be tricky. But like I say, basically, I don't have solutions to these problems. It's not like climate change where you can say, for God's sake, stop burning carbon and you'll be okay. It's not like that.
All right, thank you. Very helpful. I'm coming back to you now, Bill. Like my former CIO hat is on right now. So when I hear this, I hear opportunities, risks, and my brain is spinning. Not exactly, I'm sure people that are developing strategies around AI are early in that process. What do you advise, especially when you speak to some of our clients, on how do you respond to this? How do you prepare? Like, so you're not lost in marbles in your mouth when your CEO or leader of the organizations ask you about this particular technology.
So a lot of folks, public agencies, commercial, we're focused on responsible AI, and it's a great way to help us mitigate the risks that we can address. It's certainly not the existential risk that we're talking about as well, but what I say is this is a task that's so important, you just don't give it to your data scientists and your IT people to do. You need the business stakeholders. This is a team sport in AI to address these kind of risks. And just one question that I still want to ask.
Please, go ahead.
Earlier, Geoffrey, you asked a question that we posed to Ray Kurzweil about digital intelligence, and he returned the favor and he has a question for you. And I'm going to paraphrase it because it's
Well, just one thing. He didn't answer my questions.
That's
but I
true.
have to answer his.
That's true. I did notice that. He kind of skirted around it. Yeah. But if you could do the favor and set an example for him and address his question. So he states that biologically, humans have progressed. We're living longer. And with the advent of simulated biology, we're going to make dramatic increases there. He also talks about, in terms of how much income we make, that's also increased over time. He cites tenfold. And he has examples in 50 different areas of these incredible exponential improvements in humankind. And he states that it's not us versus AI, it's the combination of human and AI methods that will bring about these changes. His question to you is, how do we limit AI without losing these vital types of progress?
Okay, so I basically agree with him that AI can do incredible things for us. In that sense, I completely agree with him. And I think that's why we're not going to limit it. I don't think it's feasible to get people to stop doing AI and to stop developing it further because of the incredible things it can do for us in areas like medicine, but also in areas like making sort of all tedious jobs more efficient. Anybody who has to produce prose in a tedious way, they can make it much easier, like letters of recommendation, which professors know are tedious. So we're not going to stop the progress because of the wonderful things it'll do for us. But I think one thing Ray's got slightly wrong is that I think that digital intelligence has a very different flavor from biological intelligence. I've only begun to think this recently. A few years ago, I thought you'd always make it better by making it more like the biological intelligence. But the idea of a kind of harmonious collaboration of these two kinds of intelligence, I think falls apart when they become very different kinds of intelligence, and when one's much smarter than the other. And when digital intelligences can share what they know with other copies of the same model, and they can't share it with us in the same way. It's just very slow and tedious to explain to us. So I think he's sort of wrong about that. I also think that it looks to me like he's a bit worried about dying and he just needs to get used to the idea.
Okay. That's it.
Right, go and follow. You have a follow for that?
No, I actually have one last question is, and you touched upon it about reasoning. There are many out there in the industry who would say that ChatGPT, GPT-4 is merely a statistical model and just trying to figure out what's the next best word. What's your view on this?
Okay, it's a very good question. That particularly linguists of the Chomsky school, who think that language is innate, argue this stuff isn't really doing language. It doesn't really understand. It's just a bunch of statistical tricks for predicting the next word. So the first thing to say is that if you ask, what does it take to be really good at predicting the next word? For example, suppose it's the first word of the answer to a question. You have to understand to predict the next word. You can do quite well just on correlations between words, pairwise statistics or triplewise statistics. You can do a reasonable job of doing a lot better than chance of predicting the next word, but you can't do a really good job. To do a really good job, you have to understand what was said. So the amazing thing is that using the backpropagation algorithm, you train a big language model, and its only goal in the fine-tuning is to predict the next word. But that goal is sufficient to force it to understand what's been said, because that's the only way you can predict the next word. And when they say it's just statistics, statistics means different things to different people. So there's a specific sense where you're dealing with correlations and sort of low-order statistics. And that's what Chomsky means by statistics. That's what he thinks statistics is. And in that sense, it isn't just statistics. Previous language models were. Things like trigram models that Google used to use for translation and so on, they were just statistics in that sense. But these models are quite different. So they get these sentences, they convert each word into a big vector of feature activities, and they've invented the features. And then they learn billions of interactions between features, and as a result of all these feature vectors interacting, they can predict the features of the next word. And That's very different from normal statistics. It involves creating these features. They can capture very high-order correlations. And so in the sense in which it's doing statistics, everything's statistics. Mm. So saying it's just statistics doesn't mean everything, because in that sense, everything's statistics. Yeah. So I think those people are just completely wrong.
Okay. Let's go further with the large language modules. Are there specific examples you can share of what they cannot do?
Well, I already gave you one with the brothers and sisters.
Oh, that's true. Yes, yes, yes. But in terms of industry application.
Oh, industry applications. I don't know enough about the various different industries and how you'd apply them. I suspect not. I mean, the industry in which they're currently least useful is probably plumbing. Because particularly plumbing in an old house.
Yes.
If you do plumbing in an old house, you need to be very inventive, and you need to be very agile, and you need to be able to get your fingers into funny places. And they're not good at that yet. But they are getting a lot better, and they're getting much more dexterous. So even plumbing isn't safe. I mean, you know, being a professor was gone a long time ago, but even plumbing isn't safe now.
Wow, okay, okay. So on that note, and I've heard you say this before in previous talks in terms of just opportunities, you want to elaborate a little bit further on where AI may not, like, is there any areas of industry it will not touch, or do you see it touching every role, every industry?
I can't see anything that it won't touch.
Wow.
Anything that involves intelligence. So anything that we used to think of as specifically human, it's going to touch all of those things.
Gotcha. So again, in this era of exponential IT, the theme of our conference, as leaders, we've got to be preparing for this, right? So is there anything you would add, Bill, as you speak to clients in terms of that preparation process on even where to start?
Same thing as we advise people pursuing AI responsibly is this is a team sport. You have to break out of your silos of IT, get involved with the business stakeholders, get them in the same boat.
Excellent. So keep on learning and keep on learning together. Geoffrey, we're running up to the close of our time here. Are there any closing comments, parting thoughts, inspirational stories, or ideas that you want to share with our audience?
So one thing I would emphasize is we're entering a time of huge uncertainty. There's basically, we've never been here before. We've never confronted the possibility of things much more intelligent than us being around. Even though we created them and we maybe can still control them, we've never been there before. And it's very hard for people to get their heads around the idea there might be things much smarter than them. We're so used to us being in control, us being the smartest things around. We really don't know what's going to happen. So although there are many very depressing dystopian possibilities, we don't actually know anything for sure, and predicting anything more than 5 years ahead is fairly hopeless, because so many things will change. Like 5 years ago, people wouldn't have predicted we'd have large language models like we have now. 10 years ago, people would have been very confident that in 10 years' time, you wouldn't have a large language model that could answer any question you give it better than the average person. So we just don't know what's going to happen. And I think that's the most important thing to be aware of, that it's all very uncertain. And then the next most important thing is, I think we need the brightest minds working on the issue of how we keep it under control.
Excellent. Once again, let's put our hands together for Geoffrey Hinton.